So again, welcome to NX for Manufacturing Tech Tips. Today's tech tip is on how to create an NXCAM custom operation template. Demonstration will last approximately 20 minutes, and then we'll stay on the line and open up a chat window for Q&A. With that, I'll turn the session over to Mark Reif. Welcome, Mark. Let's get started.
Good morning, Derek. Glad to be back again this week. As Derek said, this is the second tech tip we're doing on customization. I actually expect there to be several more next year. We know that we want to cover setups, we want to cover the file new dialog, toolbars, journals, lots of areas here we want to touch on. So this is just really the beginning, I think, of a series. I think the best way to learn the customization is to do it in small bites, and that's really what the tech tips is all about. Last week we got our environment created, and we ended with creating a custom operation template just to demonstrate that the environment was working. So that's what we're going to pick up on this week, and we're going to create a different kind of template. Instead of a single operation, we're going to do a geometry group that will contain several operations, tools, and all that. A little bit of review, especially I know those of you that are experienced customers understand this, but we have prospects and new people in the room. I want to make sure we're clear on the terminology before we get too far into it. When I talk about an object in CAM, that's one of 5 things. We have operations, and then we have 4 kinds of groups: tools, geometry, methods, and programs. And when we create new objects, we always do it from a template. So, and then these templates have parameters, they have dialogues, they have the tooltip, and anything can be made into a template for reuse. So today what we're going to focus on is this group of objects, being able to make a single template for a whole group of things together that can be reused as a package. Another way to take a look at these groups in the operation, we need to remember that in NX, every operation really has 4 parent groups. You'll hear this called parents. You'll see the location, and these are represented by the 4 different views in the Operation Navigator. So every operation has to have a program and a tool and a geometry group and a method. And of course, these are the things that it inherits from each of these, so that when you hit generate a tool path, we get the right results. So we're getting, the tool from one place and the stock from someplace else. This is pretty well known if you're an experienced CAM user, but if you understand this slide, then everything else in NXCAM becomes fairly straightforward. So when we do go to create something, and we go to the create dialog for, say, an operation or a tool, we talked about this a little bit last week. This type is actually the part file where the templates are coming from, and the subtype is what's available. So the question is, what shows up? Because there's many more operations in this template than what you see here, and that's what the template setting does. We'll touch on that for a second before we go into the demo. Also note that when you do create an operation, you do have to specify the 4 parent groups. That's what these locations are. So when we have a template and we have an object in it, we have what we call template settings, and there's 2. And the first one is object can be used as a template. This means that if somebody uses this part as a template, this object is going to show up in the create dialog. That's what determines whether this shows up as an icon when I go to create operation or create tool or create geometry or not. That's what the first one does. So that's pretty easy. The second one is a little trickier. What the second one does is says creative parent is created, and we used to call this load with parent. What this means is if the parent is created, then this is created. So in the case of a group, it's fairly straightforward. If I'm a tool, for example, and the tool's in a pocket, that would mean that if that pocket was ever created, the tool would also be created. It just goes along with the parent. Whenever the parent's created, the child also goes. For operations, it's a little trickier because operations have 4 parents. So the parent that matters is the geometry parent. So if the geometry parent is created, then the operation is also created. But we don't forget about the other 3 parents. We retain those other 3 parents. So that means that if an operation has a specific tool, for example, as a parent, and I'm using it as a template, if that tool exists in the work part, that's where we put the operation. If the tool does not exist in the work part, then we will create it. We'll bring it in from the template just like we were creating a tool. So we preserve the 4 parents that the operation had in the template part when we bring it into the work part. So with that, and I know that's a little confusing, but hold on, I think it'll make sense once we do the demonstration. I'm going to go in and create a template for a process. I'm going to find a process that works, that we want to reuse, and I'm going to make that a template so that I can use that on other parts that have similar geometry. So what we have here is this is the environment that we created last week. If you remember, we have our special shortcut that uses our environment and our resource area for our templates and our user tools where we put the bitmap files. So what I'm going to do is fire up my custom version of NX 8.5. This is the one we left off with last week. And I'm going to open up a part that has a successful process in it. So this is a representative part of a kind of pocket that we cut in my shop, and it's a little bit special. If we take a look at it, this is we start off with a cavity mill operation to rough it out. Then we do a little relief cut. You can see this cut actually goes below the floor around the wall, where I'm relieving the floor against the wall. Then we come in with an inward follow perfect cut to finish off this pad we've left in the center. We don't want any sharp moves on that because we're trying to hold a real flat floor. And the last thing we do is we go up and we chamfer this top edge. We take a look at that and verify. You get a better idea of what this looks like. So it really doesn't matter what this process is. Just the important thing is that I have this process. I know it works. My programmers like it. The guys at the shop like it. We know what tools to use. We know the speeds it feeds. Everything is set. So I want to be able to reuse this process for other pockets that have a similar function. Okay, so there's 4 operations here that I need to reuse. Also in this part, if we look at the other views, you'll see that in the machine tool view, you'll see that I've got pockets 10, 11, 13, and 14 contain tools that I'm using for my operations. I've got another pocket here with a tool I'm not using. If we look at the geometry view, you'll see I've got these in a mill area group, which is my pocket. This is where I choose the cut area in the walls. I've also got a method defined because I like to know that I've intentionally violated the part. So on my tool paths where I'm intentionally going into the part, I'm drawing them in a pink color instead of the normal cyan color. So I have a method for that. And the program we see, it's this program 1, 2, 3, 4. So what I want to do is I want to reuse this. And remember we talked about the template settings that the geometry parent is the important one. So this is what we really need to use to capture the whole process. So I'm just going to take this and I'm going to copy the mill area group. This is a group that contains the operations. I'm going to just make a copy of that. And now I'm going to go get my template part that we've been customizing. This is the same one we used last week. And if we look at this is a copy of the original mill contour part. We see here's that special cavity milling operation we made last week. If we look at the tool view, there's really not much in here. There's a couple of pockets and a carrier. The program view is just program. The method view has our standard 3 or 4 milling methods in it. So I'm going to go to the geometry view here. And I'm going to go down to the end of my geometry items, and I'm going to paste. And what that does is I just added that mill area group from the other part into my template. Now what's nice about this is when I pasted it, it follows the same rules as the template. So I got all my operations, and I also got everything else I needed to go with it. So if I go to the tool view now, we'll see 4 pockets have been added. And these have the tools and the operations that came out of the other part. If I look at the method, we'll see here's my new method, that mill finish pink, that was added. If we look at the program view, we'll see that I've added a new program here for these operations. So everything came in that I need to recreate this process. So now what I want to do is decide how I want this to be available when somebody uses this part as a template. I really don't want a user to go in and create this cavity mill operation or create this floor wall milling operation. I don't want them to do that. I want them to only create the group. So what I'm going to do is select my operations, and I'm going to right-click in here to go to my template settings. And by default, on an operation, it's set up so that it can always be reused as a template. I'm going to turn that off. What that means is now those will not show up in the dialog when I go to create operation. And I'm going to turn on create if parent is created. That means that whenever this My Pocket mill area group is created, these 4 operations are going to come along with it. The same thing that happened when I did the paste. So that's how I want this to be set up. Now let's take a look at the geometry group itself. In this case, I want to make sure that this is a template. When I go to create geometry, I want to see this on the dialog, and I don't want to do create if parent is created. If I were to check the second box, and we look in the geometry view here, that would mean any time that an MCS mill was created, a My Pocket would also be created. And the cavity mill. All this will get created every time. So you have to watch who the parent is and whether you want it to be created with the parent or not. So here, I want to create this, but I don't want it to be created with the parent. Okay, the other thing I want to do is set up the tooltips. You remember when we did the special cavity milling operation, I assigned attributes to take care of the tooltip. So let's take a look at those again. And these are the ones we assigned last week. These are special text and pictures that come up in the pop-up. And the reason we do this is to help the user select the right thing in the dialog, right? We want to give them all the help you can to make the right choice. We're going to publish this for reuse. It needs to be understandable. So we have a group here we use for these attributes for the tooltip, and I'm going to just copy this group right out of the attribute dialog. And then I'm going to go find my geometry group. And let's look at the properties on this. We'll see it has no attributes defined at all. So let's just go in and paste those in there. And let's start changing them. The bitmap is set to my tooltip. I have another one that we're going to copy in. And it's called my pocket tooltip instead. So I'm going to just change the name. This is the bitmap that's going to be shown in the pop-up tooltip. Okay. We probably want to change the name of this also. Just call this my pocket, and let's give us a little hint for the user on what this is really for. This is a process for a pocket, let's say, with relief around the floor, right? For example, and this could be whatever helps your users make the right choice. In our second paragraph, we usually try to tell the user what has to be selected. So I'm going to say that, select the floor as cut area and select the walls. These would be my instructions for the user on what he has to select. And my last one here is what do we recommend this for? I would say interlock pockets, for example, would be a good place to use this. And again, this is up to you, whatever you think is good for your users. So that's all I really need to do to define the tooltip. Let's look at the operations. If I look at this operation, this is our standard cavity mill dialog. I really don't want to show this to the user because I don't want him to change certain things. For example, since this is part of this pocket group, I don't want the geometry selected in the operation. I only want it selected in the parent, and I want to keep the user out of trouble. So I'm going to customize this dialog to change some things. Let's go in and go to Object Customize. And let's look at my geometry group. For example, I'm going to I'm going to remove this selection. I'm going to remove part, blank, check, cut area. I'll leave him trim boundary. He might have to do a trim boundary. I'll let him do that in the operation. If we look at tool, for example, I really don't want him to be able to change the tool because I've got it locked in already, so I'm going to delete that. I'm going down into my path settings. I've set this already up with a nice trochoidal cut. I've got it set just the way I want, so I don't really want him to change that. So I'm going to delete the cut method. I'll delete the step over. I'll delete the additional passes. I'll let him set the depth for cut. Okay, so what I'm doing is just deciding what I want on the dialog for the user and what I want to hide. Now I can always change it, or a sophisticated user could always find a way to restore it, but out of the box I want to just present the things I think the user should be doing. And I would do this for all 4 operations. We'll just do it on the cavity milling right now. So I'm going to save this operation now. Let's go out of NX. And you may remember that I added a picture for the tooltip. We need to go look where my bitmaps are stored. If you may remember, that's under User Tools, Bitmaps. And these are the bitmaps we added last week. I have the bitmap for the tooltip. I also have a bitmap for the icon. By default, this is a name match. So because I call the group My Pocket, an icon My Pocket will show up. So I'm going to take these 2 bitmaps and I'm going to copy them over into my UGI bitmap path for this case. So now let's go back up. Let's start NX again. Let's see how to use this template. So what I'm going to do is open up a part that has similar pockets in it. This is a part, it's brand new. It's my job to program it, and I know that I've got a process for these pockets that I'm going to reuse. So let's go and create a new setup for this. I'm going to go to File, New, just my general setup. And if we look in the Operation Navigator, we see we have this program, 1, 2, 3, 4. That's nice. We also have 30 pockets defined. And I'm going to show you this because some things are going to be created and some things are not. On the geometry view, all we really have is the workpiece. And in the method view, we just have 3 mil methods is all. So let's go to the geometry view and let's select our part in blank. So I'm going to choose the entire thing as my part. I'll use a bounding box for my blank. And that's it. So at this point, let's try my new template. I'm going to go to Create Geometry, because remember the geometry is the one that matters for operations. And I'm going to change from mill planar to mill contour. You can see on the second line, this is the group we added, the My Pocket. This is a mill area group, but it has a different icon because I said so. It has a different tooltip. And this is the text that we entered in the attributes. So this way my user can hopefully pick out the right one. Says, okay, that's the kind of pocket I have to do. Even though it's modeled, as you see, with sharp corners, this is the machining process we want for this. So I'm going to go ahead and use this. And I'm going to put this under my workpiece because that's where the part and blank are defined. This is okay. I remember those instructions that I had to pick the floor and the wall. So let's go to Cut Area. And I'm going to pick my floors here. And let's go to Walls. And I'm going to use tangent faces. And I'll pick all my walls. That looks pretty good. And now let's just generate. And we'll see what happens. Okay, there's the roughing passes. That's the trochoidal cavity milling that I had set up. There's the pass that relieves the floor. You can see it going underneath. There's our pass to finish the pads in the middle of each floor. There's our chamfer cut. That was pretty easy to do. I didn't have to look at an operation. So we haven't even seen an operation yet. That's just from that group, because once the process is defined, if it's a similar part, all you should really have to do is pick new geometry. That's the only thing different between this and my template is the geometry. Everything else is exactly the same. Let's take a look at this. Let's verify this. Just See what it looks like. This will take a second to do. But we'll see. There's the cavity mill to rough that out. And again, whatever you find works for your shop, this is the idea. We don't want to use it to have to go in here and create cavity mill, change the step over, change the cut pattern, change the depth of cut, select the tool, if we know what works. So my assumption is that in your shop, somebody knows what works, right? We can't dictate a process for you, but if you have a process that works, what I can help you do is reuse it so that everybody uses the same process over and over. It's better for your programmers because it's easier. Once they agree, it's easier. And I think it's much better on the shop floor because the operators get consistent programs. They're not, I mean, I've worked in shops where they had to look at who programmed it so they would know what to expect. And it shouldn't be that way. If your company has a process for this that works, then we want everybody to use it. So we can see here we got exactly the same cuts we did on our template, but it's applied to these three different shaped pockets. One thing to look at is what do we actually get when we did that? We got the operations here. If we look at the methods, we see that this this pink method was added. That wasn't there before. In the tool view, we see that the tools were dropped into these 4 pockets. So no new pockets were created because they already existed. Remember I said we retained the parent, so that's why they got put into these pockets, whereas in the method, it was a new method, so it got created. If we look at the program view, we see that we already had that program 1, 2, 3, 4, so they got dropped right in there. If I take a look at that cavity mill operation, so my Joe user, he does this, he says, hey, that's really nice, I need to change my my cut area though. So he goes into cavity milling, and the first thing we find is cut area is not there. Well, the reason is because it's in the group, right? We don't want the user to change it. We want him to change it in the group. So I've hidden it away. He thinks he's a wise guy. He wants to change the tool. I can't do that either, right? I can change my registers, but I can't really pick a different tool from this dialog. Of course, there's other ways to do it, but again, we're trying to present the most likely scenario to the user first. And again, you notice cut pattern is different. He can't change it from trachoidal, let's say, to zigzag because I've taken that off the dialog. So these are some of the things that you can do when you're doing the customization to preserve a process. And just to review, we use the geometry group to capture a series of operations. And when we use that as a template, we brought in the group, the operations, and all the tools and methods and programs that those operations required to generate good toolpaths. So that concludes this part of the demonstration. With that, I think I would open it up for questions. And I think I know one we're going to have immediately is how do we do the chamfer operation? I've already had some people ask that, so I thought I would show that real quickly. This is a solid profile 3D operation. If you look at this operation, this is where you find it. It's really designed for something like a punch or a trim die to machine the vertical land that we have and follow the profile up and down. But it doesn't have to be contoured. It can be straight. So in this case, I have it for the walls. I told it to follow the wall top. You can follow the wall top or the bottom. I said follow the top. And I said part stock -3, so that meant go 3 millimeters into the part. And for the Z depth offset, I said 3. That means go 3 below the top of the wall. So in effect, we're taking a chamfer cutter, and from wherever it would, let's just go. So from wherever it would normally be, we're dropping it down 3 and over 3 to create the chamfer of the part. So pretty easy way to chamfer things, and it'll follow wherever the top edge of the wall is. That's what it's going to follow. Another question I think is how does this differ from feature-based machining? I think the main difference is that in this method, you are determining what the process is. You are selecting the tools. You're selecting all the machining parameters, your depth of cut, the feeds, the speeds. You're doing everything. What this allows you to do is just take a known process and reapply it to something where the only real difference is geometry. In feature-based machining, the system is selecting the process, The system is selecting which operations. It's selecting the tools for the library. It's setting step over. It could be setting tolerances based on PMI information. It could be selecting the tool based on the corner radius of the part or the depth of the pocket. So in feature-based, the system is really selecting the process based on the shape of the part. Of course, that requires rules. We have out-of-the-box rules, but more than likely, you'll have to do some work to customize those rules. So if you want the system to do that, if you do lots of different kinds of features that have lots of different kinds of processes, then feature-based is probably a really good investment. If you've got some real common features like this where you'll always use the same process and you can remember what they are, then a template is probably an easier way to just grab and reuse a known process. So with that, Derek, I think I turn this back over to you.
Yes, thanks, Mark.
And,
that was fantastic.
Okay.